Hey everyone, and welcome back. Today we're going to be doing a deep dive into bioremediation.
Sounds cool.
Yeah, it is actually really fascinating stuff, and we've got a lot of really uh, interesting sources that we'll be drawing from.
It's a pretty broad topic, though.
Yeah, for sure.
Mm.
We'll be talking about everything from, the Exxon Valdez oil spill
Mm.
to those PFAS forever chemicals that you hear so much about these days.
And even using plants to clean up military sites.
Yeah, oh, yeah, that too. That's some seriously impressive stuff. So, yeah, why don't we just jump right in? Let's start with that Exxon Valdez oil spill back in 1989. 11 million gallons of oil spilled into Alaskan waters.
It was a huge environmental disaster.
Yeah, absolutely devastating. So how did bioremediation play into the cleanup efforts for that?
Well, initially they were using traditional methods like booms and dispersants.
Right, the typical stuff you think of.
Exactly. But it wasn't as effective as they'd hoped.
I see.
And then scientists realized, hey, wait a minute. There are already oil-eating microbes present in the ocean. Oh, interesting. So they're just naturally there.
Yeah, they're just doing their thing.
So then they decided to try and work with these microbes rather than, I guess, just relying on the traditional methods.
Exactly. They figured why not harness the power of nature, right?
Makes sense. So how did they do that?
Well, the EPA and Exxon actually teamed up, and they started using fertilizers that were specifically designed to boost the effectiveness of these microbes.
Oh, wow. So they were like feeding them almost.
Yeah, basically. Like giving them a power up to help them break down the oil more efficiently.
I mean, it sounds pretty smart, but I also wonder about adding fertilizers like that. Isn't that its own kind of environmental concern?
Yeah, for sure. That's a valid concern. Scientists have to carefully consider the potential downsides.
Right. You don't want to solve one problem and create another.
Exactly. It's all about finding that balance between effectiveness and minimizing any negative side effects.
So did it work? Like, was it successful using those, fertilizer-boosted microbes?
Well, it definitely showed promise. And what's really cool is that research is still ongoing to find ways to make these microbial helpers even more efficient and targeted in case of future spills.
That's great. So it sounds like we're learning more and more all the time about how to use bioremediation effectively.
Absolutely.
Okay, well, I want to move on to talking about plants, because they're not just cleaning the air, right?
No, not just the air.
Like, I read that they're being used to tackle some pretty nasty stuff at old military sites.
Oh, yeah, definitely. For example, the U.S. Army Corps of Engineers has been using modified switchgrass to clean up explosive residues.
Wait, hold on. Back up for a sec. Modified switchgrass. What does that even mean?
Okay, so basically scientists have been able to enhance the natural abilities of switchgrass through biotechnology.
Yeah.
They're essentially given a genetic upgrade.
Wow, a genetic upgrade.
Yeah, it's pretty wild. And this upgrade lets them absorb and neutralize and even store even more of those harmful explosives than they could naturally.
So they're like super switchgrass.
Right.
And this is better than like digging up all the contaminated soil.
Oh yeah, way better. Those traditional methods, like digging and removing contaminated soil, are incredibly expensive and time-consuming.
Plus, you've still got to deal with the contaminated soil somehow.
Exactly. So this is a much less disruptive approach.
That makes sense. But I got to ask, modifying plants like that, doesn't that raise any concerns?
For sure, anytime you're talking about genetic modification, there are always potential risks to consider.
Right. Like, what if these super switchgrass plants escape and start taking over everything?
Well, that's why there's rigorous study and assessment for any kind of genetic modification to be sure the benefits outweigh any potential downsides.
Okay, so it's not like they're just doing this willy-nilly.
Definitely not. There's a lot of research and monitoring involved.
Good to know. Okay, before we move on to something else, I want to touch on those forever chemicals you hear so much about.
PFAS.
Yeah.
Yeah, PFAS.
Yeah.
Could you give us like a quick rundown on what they are and why they're such a big deal? Sure. PFAS stands for per and polyfluoroalkyl substances.
Okay.
Basically, they're a large group of man-made chemicals
Mm-hmm.
that are incredibly persistent in the environment and in our bodies too.
Hence the nickname forever chemicals, I guess.
Exactly. And the problem is you find them in just about everything. Nonstick cookware, firefighting foam, food packaging, you name it.
So they're everywhere.
Pretty much, yeah.
And they're bad for you.
The big concern is they've been linked to a bunch of health problems, like immune deficiencies, liver cancer, thyroid issues.
Yikes, that's scary.
Yeah, and the CDC did a study and found that something like 98% of Americans have some level of PFAS in their blood.
98%, seriously.
It's pretty alarming.
So what are we doing about it? Like, how do you even clean up something that's called a forever chemical?
It's a huge challenge. The EPA is working on restricting the use of PFAS in new products, which is a good start.
Right, so preventing more from getting out there.
Yeah, but the bigger problem is what to do about the PFAS that's already out there.
Okay, so is bioremediation part of the solution here too?
It could be, yeah. Researchers are developing some really innovative techniques specifically for PFAS.
Like what?
Well, one promising approach involves using special sponges.
Sponges.
Yeah, special sponges that foster the growth of microbes that can actually break down PFAS.
Wait, so you're telling me there are microbes that eat PFAS?
Yeah, not exactly eating, but yeah, they can break them down.
That's incredible. So these sponges are like what? They provide a home for these microbes?
Exactly. They create this perfect environment for these PFAS-eating microbes to thrive and do their thing.
I mean, it sounds crazy, but I guess it makes sense.
And the early results are pretty encouraging. One company that's been testing this technology reported removing up to 90% of PFAS from water samples over a year.
90%. That's amazing.
It is pretty impressive, right?
So it sounds like bioremediation really is offering some real hope for tackling these tough environmental problems.
It definitely has a lot of potential. And the cool thing is we're really just scratching the surface of what's possible.
You think so?
Yeah. As we understand more about these natural processes and as biotechnology keeps advancing, we're going to see even more effective and innovative uses for bioremediation. I'm sure of it.
Well, that's great news. I'm excited to see what the future holds for bioremediation. Now, I know we've been focusing on cleaning up things like oil spills and chemicals, but can bioremediation be used for other types of environmental problems?
Oh, absolutely. Researchers are exploring the potential of bioremediation for all sorts of things, like plastic pollution in the oceans, heavy metal contamination in soil.
Wow, so many possibilities. Plastic-eating microbes in the ocean.
It's a real possibility.
And what about those heavy metals? I remember learning about how they can be super toxic.
Yeah, and they can accumulate up the food chain, which is a big problem.
Right, it's not just about cleaning up the soil itself, but preventing those heavy metals from getting into the things we eat.
Exactly. But luckily, there are certain plants like sunflowers and some ferns that have this natural ability to absorb and accumulate heavy metals from the soil.
So they're like little natural vacuum cleaners for heavy metals.
You could say that, yeah.
Wow, that's fascinating. It seems like with bioremediation, we're really starting to change our perspective on how to deal with environmental problems.
Yeah, I think you're right.
Instead of just trying to fix things with harsh chemicals or expensive procedures, we're realizing that we can work with natural systems to find more sustainable and effective solutions.
It's a much more holistic approach.
Exactly. So it's not just about cleaning up the mess, but about restoring balance and working with nature instead of against it.
That's it. Recognizing that we're a part of nature, not separate from it.
I like that. So I'm curious, for the non-scientists out there, what can we do to support the development and use of bioremediation?
That's a great question. I think first and foremost, staying informed about these advancements is key.
So read up on it, stay curious.
Exactly. The more we understand about bioremediation, the more we can advocate for its use and support policies that encourage its development and research.
Yeah, and I think it's important to remember that even small actions can make a difference. Supporting companies that are committed to sustainable practices and using bioremediation.
Absolutely.
And just being mindful of our own environmental impact, Reducing our reliance on products that contain those harmful chemicals in the first place.
Yeah, an ounce of prevention is worth a pound of cure.
That's a good one. So it sounds like we've got a lot to be optimistic about when it comes to bioremediation.
I think so, yeah. It's definitely a field with a lot of promise for the future.
Okay, well, before we move on to some more specific examples, I want to dive a little deeper into some of the stuff we've already talked about. So let's start with blight, those plastic-eating microbes you mentioned earlier. Is that really a thing, or is that, still in the lab?
Oh, it's definitely a hot area of research.
Okay.
And there have been some pretty promising pilot projects. Not large-scale stuff yet, though.
Okay.
But, one company has developed a process using enzymes.
Enzyme.
Yeah. From bacteria they found in compost heaps. And these enzymes can break down certain types of plastic.
So instead of just throwing all our plastic in landfills or having it end up in the ocean, we could actually, break it down.
Potentially, yeah.
Yeah,
But there are definitely challenges.
I bet.
It's still a pretty slow and expensive process right now.
Yeah.
And it doesn't work on all types of plastic, unfortunately.
So not a silver bullet.
But it's a huge step in the right direction. And, researchers are always working on ways to make it more efficient
Yeah.
and expand the range of plastics that these enzymes can break down.
Right, so they're working on it.
Yeah, for sure.
Still, it's pretty amazing to think that we might be able to use these tiny little organisms to solve such a big
The
problem.
power of nature, right.
Yeah. And what about those heavy metal absorbing plants? Are we actually using those to clean up stuff?
Yeah, actually, there's a whole technique called phytoremediation.
Phytoremediation.
Yeah, it's basically using plants to remove pollutants from soil and water. And for heavy metals, certain plants are particularly effective, like sunflowers.
Sunflowers.
Yeah, and mustards. They're really good at absorbing those heavy metals.
So you're telling me I can plant a bunch of sunflowers and they'll suck up all the toxic heavy metals from my backyard?
Well, it's not quite that simple, but yeah, they can absorb and accumulate high concentrations of heavy metals in their tissues.
So they're like pulling it out of the soil
Exactly.
and then what, you just leave the plants there or?
Once they've done their job and accumulated a good amount of those metals, they usually get harvested
Okay.
and disposed of safely. Sometimes they can even be incinerated.
Oh, wow.
And then the ash, which has all those concentrated metals in it, can be processed further. You can even potentially recover some of those metals.
Really? So it's not just cleaning up the environment, but you can actually get something valuable out of it.
Yeah, exactly.
That's cool. You know, thinking back to that Exxon Valdez oil spill and those oil-eating microbes, did scientists have to like create those microbes in a lab or were they already there?
No, they were already there in the ocean naturally.
Oh, so they were just hanging out.
Yeah. Scientists didn't create them. They just figured out ways to make them more active.
Oh, so it was like giving them a boost.
Exactly. Helping them break down that oil more quickly and efficiently.
So a lot of times these solutions are already out there. It's just a matter of finding them and figuring out how to utilize them.
Yeah. Nature's pretty amazing like that. It's got a lot of answers if we just know where to look.
Right. So how long does all this take, this bioremediation? Is it a quick fix or does it take a while?
It really depends on the situation. How much contamination there is, what kind of pollutants you're dealing with, the environmental conditions. It all plays a role.
Yeah, makes sense.
Sometimes it can be relatively quick,
Okay.
but other times it can take years or even decades to get the results you want.
Wow. So it's not a magic bullet.
No. It's more like a patient and persistent approach, using nature's power to gradually restore things to how they should be.
Okay. Now I want to go back to those special sponges that help break down PFAS. Can you explain how those work in a little more detail?
Yeah, sure. So basically, those sponges are designed to provide the perfect little home for the microbes that can degrade PFAS. You have a really large surface area,
Yeah.
which gives those microbes lots of space to attach to and create what we call biofilms.
Biofilm.
Yeah, it's like a whole community of microbes working together.
So it's like building them a little apartment complex.
Yeah, kind of like that.
Yeah.
And the really cool thing is you can use these sponges in different environments. Like you can put them in groundwater wells or even incorporate them into filtration systems for drinking water.
So you can use them to clean up contaminated water.
Exactly. And researchers are even working on more durable sponges that can last longer in tougher conditions.
Yeah, always improving.
That's the spirit.
Okay, well, this has been really fascinating. I'm feeling pretty optimistic about the potential of bioremediation to solve some of these really complex environmental problems.
Yeah, me too. It's a really exciting field.
Okay, so before we wrap up this deep dive, I want to touch on something else. Ethical considerations.
Oh, yeah, that's important.
So what are some of the ethical things we need to think about with bioremediation?
Well, one big one is unintended consequences. When you start introducing modified organisms or changing natural processes, you really have to be careful about what might happen to the rest of the ecosystem.
Right, you don't want to create a new problem while you're trying to solve an old one.
Exactly.
Are there other ethical concerns?
Transparency and public engagement are super important.
Okay.
It's really crucial to involve the communities that are going to be affected by these bioremediation projects and to be open about how it works and any potential risks.
Yeah, so it's not just about the science, but about how it impacts people.
All right. Building trust and making sure everyone's informed is really important.
Makes sense. Open communication is key.
Yeah, for sure. And remember, bioremediation isn't just about cleaning up pollution. It's about restoring balance, making sure the environment's healthy for generations to come.
Well said. Okay, I think we've covered a lot today. We've explored this amazing world of bioremediation and how it can help us deal with all sorts of environmental problems.
From oil spills to plastic pollution, heavy metals, we've seen how nature can provide solutions if we're willing to work with it.
And we've talked about the ethical considerations too.
It's not just about the science, it's about the people and the planet.
Exactly. So as we resurface from this deep dive into the world of bioremediation, I want to leave our listeners with the thought: what other crazy applications of bioremediation are out there? What haven't we even thought of yet?
But that's what's so cool about this field, right? The potential is huge. We're discovering new stuff all the time, like using bioremediation to clean up air pollution.
Air pollution.
Yeah, like some fungi can actually break down harmful pollutants in the air.
So not just soil and water, but the air, too.
It's pretty wild, right?
Yeah, that's amazing. It feels like we're just getting started with bioremediation.
Oh, totally. And with biotechnology advancing so fast, who knows what we'll be able to do in the future?
It's like we're changing our whole mindset. We're not fighting against nature anymore.
Right.
We're working with it, recognizing that it can heal itself.
It's a whole new way of thinking.
So for our listeners out there who are interested in bioremediation, what can they do to learn more or even get involved?
Well, there's a lot you can do.
Hmm.
Start by looking into local organizations or groups that are focused on environmental restoration and bioremediation.
Okay.
A lot of universities and research places are doing some cutting-edge work in this area, and they often have volunteer opportunities.
So you can actually get hands-on experience.
Yeah, definitely.
And I'd say even just staying informed is a big step. You
Yeah.
know, reading about the latest developments in bioremediation.
Absolutely.
The more people know about these solutions, the more they can advocate for them.
Exactly. Knowledge is power, right?
Yeah, in this case, it's the power to create a healthier planet.
Well said.
Okay, well, I think it's time for us to wrap up this deep dive. We've learned so much about bioremediation, from oil spills and those forever chemicals to plastic pollution and heavy metals and even cleaning up the air. It's been an amazing journey.
It really has, and it gives me hope for the future.
Me too. So thanks for joining us on the deep dive. Keep exploring, keep learning, and remember, even small actions can make a difference when it comes to protecting our planet.